Hi class. So tonight for homework is assignment number 4, section 281, and your homework is a 281 worksheet. Today we are going to be finding the composition of two functions. So let's do a quick review from yesterday. Yesterday we learned indicated operations of functions such as addition, subtraction, multiplication, division. So if we want to do p of x plus q of x, we're going to take p of x, which is 2x plus 1, and add it to q of x, which is x minus 3. Combine our like terms, we get 3x minus 2. P minus q of x is we're going to take p of x, and we're going to subtract q of x from it. So I need parentheses because I want to subtract all of q of x, not just part of q of x. So I need to make sure that I'm distributing that negative to all of q of x. So after distributing that negative, it gives us 2x plus 1 minus x plus 3, because a negative times a negative is a positive. Combine our like terms and we get 1x plus 4. P times q of x means p of x times q of x. And again in parentheses because I want all of p of x times all of q of x. So I'm going to distribute 2x times x gives me 2x squared. 2x times negative 3 gives me negative 6x. 1 times x gives me positive 1x. And 1 times negative 3 gives me negative 3. So then we combine our like terms, the negative 6x and the positive 1x, and we get 2x squared minus 5x minus 3. None of those are like terms, so that's our final answer. And finally, in number 4, we have p of x divided by q of x, so the quantity 2x plus 1 divided by the quantity x minus 3. Can't go any further. We don't know how to divide polynomials yet. That'll come in Math 3. So for now, we leave our answers just like that. So that's a nice little review from yesterday. Now let's learn about composition of functions. You guys have a worksheet, so no need to take any notes in your book today. So let's look at a composition of a function. What a composition of a function is a value of a value. So we're going to first take our value, feed it into our first function. Then out comes our answer. We're going to feed it into our second function to end up getting our final answer. A composition of function looks like this: f of g of x. Or you might see this, that also means f of g of x. Don't get confused with multiplication. Composition will be an open circle, whereas multiplication will be a filled in circle. So to start, let's just evaluate functions. So p of 7 means that I'm going to substitute 7 into p of x. So that's 2 times 7 plus 1, which is, 14 plus 1, which is 15. P of 2 is going to give me 2 times 2 plus 1, which will give me 4 plus 1, which will give me 5. And P of s means I'm substituting s into the p of x function, so that will give me 2s plus 1. Variable, not like terms, can't combine. Q of 3 means I'm substituting 3 into my q of x function, so that's 3 minus 3, which is 0. Q of 2 means I'm substituting 2 into my q of x function, so 2 minus 3 gives me negative 1. And Q of t means I'm substituting t into my function, so t minus 3. Not like terms, so I can't combine them. Now let's take a look at a composition of a function. So composition of a function means that I take p of 7 and substitute it into q of x. So p of 7 I already know is 15 from number 1. So this is the same thing as q of 15, which is 15 minus 3, which is 12. Again, what we did was we took 7, substituted it into p of x to get 15, then took our answer, 15, substituted it into q of x to then get 12. So here, p of q of 2 means that I first substitute 2 into q of x, which we already did here. So q of 2 gave me -1, so now we're going to substitute -1 into p of x to get -1 minus 3, which is -4. So p of q of 2 is -4. Again, first substituting 2 into q of x, and then our answer into p of x. So q of p of 2 is going to be opposite. We're going to first substitute 2 into p of x, which we already did up here, and got 5. So p of 2 gave us 5. And then we're going to substitute that answer into q of x, which is, oh shoot, I just realized I did that last one wrong. I'll come back to it. Q of 5, which is 5 minus 3, which gives us 2. In our last example, I went backwards. So q of 2 gave us -1, but then we needed to substitute that into p of x, which function p of x is not x minus 3, it is 2x plus 1. So 2 times -1 plus 1, which will give us -2 plus 1, which is -1. Interesting. So again, what we did was we found q of 2, then substituted that answer into p of x and got -1. So that is the most basic form of composition of functions, 7, 8, 9. We can also do composition of functions just with x values. So for example, with those same two functions, if we want to define p of q of x, what that means is I'm going to take q of x and substitute it into p of x. So q of x is x minus 3. P of x is 2x plus 1. So p of x minus 3 is what we're going to be doing. So 2 times x minus 3 plus 1 gives me 2x minus 6 plus 1, which gives me 2x minus 5. And here we're going to go opposite direction. We're going to take p of x and substitute it into q of x. So p of x is 2x plus 1, and we're going to substitute that into q of x, which is x minus 3, which is 2x minus 2. So that's composition of functions. You're taking one value, substituting it into the other function, and you have to look at the order. You always work inside out. This first, that answer goes into that function. This first, that answer goes into that function. All right, you guys have the rest of the period to work on your homework. Good luck.